Rumors of GPT-4 are in the air, neuron transmissions is now solved in closed form, and mind reading is a thing now. It's Monday and welcome to mlnews. Hello and welcome to mlnews. This is your regular update of what's going on in the machine learning and AI world. Our first story is the most interesting one. Brain reading is more and more becoming a thing. There is a paper called Seeing Beyond the Brain, Conditional Diffusion Models with Sparse Masked Modeling for Vision Decoding. In this paper, the authors give a visual stimulus to a subject, a real human, and then look at their brain waves. This is non-invasive. This is fMRI brain scans, and from that reading of the fMRI, they're able to decode what the person is seeing. You can see right here, on the top you have visual stimuli, and on the bottom you have the reconstructed images. Now, what you'll be able to see is that the pixels don't exactly match. However, the semantic content is very often the same. Now, this is done via aligning the latent spaces of the encoders for the brain data and encoders from images. And this has been a long-standing problem because the training data that exists to map what people are seeing from their brain waves to the image space is just super sparse. But the authors here go around that by pre-training on unlabeled fMRI data and first get a very, very good autoencoder on that data going. Then the latent space can be determined, compressed, and then from that latent space, we can learn a conditional image diffusion decoder in order to map the visual stimuli to the encoding of the brainwaves. So the paradigm that we see in deep learning, where you want to do some unsupervised pre-training first because you have much more unlabeled data, and only then include the task-specific data and learn that on top of the unsupervised pre-trained models, also holds in the field of brain-computer interfaces, apparently. So it's pretty cool that we're more and more getting the chance to peek into people's brains. Now, this isn't yet a full thought reader or anything like this. Essentially, they disambiguate between, I believe, some 100 different classes of labels, but it's still very, very cool that you can essentially reconstruct just from reading brainwaves what kind of image the person is seeing and what about is in the image. In a related article, neurosciencenews.com writes that brain-machine interface device predicts internal speech. Now, this is a little bit different in that it's actually invasive, so this is an interface directly to the brain, but it is able to predict internal speech, which means speech that you just internally think to yourself. It is able to decode that. Now, it is not able to decode arbitrary speech. I believe they go up to about 8 words or something like this. So it's not yet exactly super accurate, but we are making big progress in that front. All right, next news. Ramin Hassani writes that they've published a new article in Nature Machine Intelligence and solved a differential equation that's been long-standing without a closed-form solution. We now have that closed-form solution, and it concerns the interactions between neurons. This is a major benefit for people who want to implement biologically inspired, sort of biologically plausible neural networks, because previously you'd have to have some sort of an ODE solver in order to even model that connection properly. And now that there's a closed form solution, you can essentially just forward and backprop through that formula. And the absolute coolest thing is that they have implemented this in both PyTorch and TensorFlow. So you can technically build in this directly into your architectures today. Now, it's not guaranteed to be like a lot better than what we currently have in terms of neuron-neuron connection, but that's not the point. The point is to get to a place where we can simulate biologically plausible neural networks as well as possible, and from those potentially learn something about the brain. And we might actually get some inspiration for how to even improve our artificial neural network architectures from this. So check out the paper and the repository in case you're interested. Alberto Romero on Substack has an article called GPT-4 Rumors from Silicon Valley. This is a summary of things that people, whatever people means, talk about currently around GPT-4. So OpenAI has been announcing like tiny bits of the next iteration of their language models here and there. And there used to be an interview by Sam Altman where he said GPT-4 isn't really going to be that much bigger than GPT-3. GPT-3, and it's probably still going to be in the text domain. It's probably going to be a bit more aligned to humans, a bit more, learning from human feedback and so on. And people were kind of like a tiny bit disappointed, I guess, because it's not, oh, we're going to build the next giant thing. But now more and more rumors are coming out that, in fact, GPT-4 might be very, well, what they claim colossal. So another scale up of 2 orders of magnitude or something like this in terms of numbers of parameters, or even 3 orders of magnitude. Although some rumors claim that it is going to be sparse, so there's not really like a one-to-one comparison. On the other hand, there are also a lot of rumors that claim that GPT-4 is going to be multimodal after all, so including text, images, videos, and so on. Basically anything they can get their fingers on. So we'll see which one of these turns out to be true. It's very well possible that they first aimed at just sort of improving GPT-3, and then all of a sudden, with recent developments around diffusion models and so on, they've now gone into the direction of, let's just do another giant leap. And from people who have apparently spoken to other people who have apparently tried the new model or a precursor to the new GPT-4, they say that GPT-4 will be just as much an improvement over GPT-3 as GPT-3 was over GPT-2. And if you remember, in case you remember, GPT-3 was a giant improvement over GPT-2. Now, is this going to be AGI and solve all our problems? Probably not. But in case this is true, in case it is really the same amount of step from GPT-2 to GPT-3 as it is from GPT-3 to the new GPT-4, then I think we're in for pretty amazing times. In any case, rumors be rumors, and I guess we'll only know when we actually see it. The new model is rumored to be released sometimes between December and February, so the wait isn't going to be that long. Now, related to this, OpenAI is also rumored to collaborate with Cerebras, and Cerebras in turn has just released their biggest supercomputer to date, which is called Andromeda, and has 13.5 million cores. Now, Cerebras is a company that builds extremely large chips. They want to do as much as they can like on a single chip, and that's why their chips are like, I think they're about yay big. I'm not exactly sure, but this absolute supercomputer is just comprised of 16 Cerebras CS2 systems. So that should give you already an indication of just how big their individual systems already are. Now, connecting them makes for a ginormous supercomputer. Now, here on the website, it says get demo, but I guess for most of you, it's not really gonna be an option to, go into business with this kind of scale, but for some of you, it might be, and you might very well want to click that button. The Meta research blog announces the ESM Metagenomic Atlas, the first view of the dark matter of the protein universe. So a lot of protein folding work has been done recently with AlphaFold and ESMFold, and now Meta releases a database of what's called metagenomics. Metagenomics is essentially, if you just go outside and you pick up a piece of dirt, there's going to be like a ton of microbes, a ton of bacteria, a ton of organic material in there, and all of that genomic material isn't necessarily something you'd find in like the Human Genome Project or something like this, yet it's still very important, for example, for ecology, for medicine, but also for human well-being. So this Metagenomic Atlas is the first database that reveals the structures of the metagenomic world at the scale of hundreds of millions of proteins. You can explore that. There is a link to the atlas right here. If you're anywhere near this world of protein folding, I guess this is a very exciting time, and I'm also excited for the progress we make on other frontiers rather than just scaling up and producing more stories about unicorns. Like, for all the criticisms that these big models get and the pressure to just scale and scale and scale, they do every now and then deliver us something like this, something that's absolutely undeniably useful for some natural science out there. And as we get better with our core research, even if that's on pictures of cats, I strongly believe that this will greatly benefit adjacent fields such as biology, mathematics, physics, chemistry, and more of the other sciences. Also on the Meta AI blog, they released a blog post called Teaching AI Advanced Mathematical Reasoning. Now, I've dealt before with some of the papers that Meta had in this regard, where they tried to come up with systems that use a prover. So there are these things called called prover systems or proof assistants, where you essentially formalize your whole mathematics inputs. So you spell out everything super formally, super descriptive, super detailed, and then you can use the system to search for new proofs by applying some proof strategies here and there. So you can say, I want to do now a contraposition of two things and so on. However, as you'll quickly discover, the amount of strategies that you can apply to a given statement to search for a proof is really, really huge. And that leaves you essentially with a search problem. So this paper uses essentially a variant of Monte Carlo tree search, the same thing that like AlphaGo uses in order to determine the next moves in a Go game, in order to determine the next proof strategy or the next proof step that should be applied in order to reach a given target statement. Again, very cool that what initially dealt with a bunch of games and was really flashy because we can now solve Go and chess much better, has developed into something that is of actual use in an adjacent field, in this case mathematics. So very cool. Check out the paper if you are interested. NVIDIA has released a paper called eDiffI, text-to-image diffusion models with ensemble of expert denoisers. This is, I would say, a typical NVIDIA paper where they don't reinvent the world, but what they do is they take what exists and they apply a strong engineering mindset to it. They improve upon it, and it just results in a very high qualitative output. So in this case, they take the idea of these text-to-image diffusion models, but then on top of that, they have an ensemble of expert denoisers. So they don't just have one denoiser like we'd be used to in a diffusion model. They have an ensemble of denoisers, which means that different models can take care of different phases in this denoising process. Also, they stage the image production in multiple steps. Now, this has been done before, but it is a very viable strategy in that you essentially have one model produce a low-resolution version of the image, and then you successively scale that up. Now, as you can see right here, all in all, that results in super high quality images that can either be done from a text description or from, as you can see right here, text plus some kind of map or some kind of mask that you draw. Or over here, you can also input some sort of a style reference image into this system. So again, it's just amazing how people are able to push forward the state of the art in such a short time. Big Science has released two new models, one called BLOOMZ and the other one called MT0. These are evolutions of their previous models, and they're mainly concerned with multitask prompted fine-tuning. We've dealt with prompted fine-tuning before in the Galactica paper, which essentially means that after you pre-trained your model, you fine-tune it on prompted samples. So like you would ask GPT-3 with a prompt to do some kind of task, you go ahead and actually fine-tune on the prompt, the input, and the output of that task to make the model learn to respond to such prompts in an appropriate fashion. And if you do that for multiple tasks, you also have the ability to then generalize to new tasks, because that will carry over from the pre-training. Specifically, these new models deal with this exact setting, but in non-English data. So a cross-lingual generalization, doing this in multiple languages and potentially also generalizing across languages. The models are on Hugging Face if you want to check them out. ICLR 2023 reviews are out on OpenReview, and there are quite a few surprises in the negative direction. So Robert Tang here tweets out an example where the authors respond to a reviewer with "response to you is a waste of time. I hope you can respect the author's work and give constructive comments instead of taking a few minutes to give a trivial suggestion. I recommend that you complete a university, maybe kindergarten course before giving your review comments." That's just lovely. Somehow believing in the good of human beings, maybe this person just like had an absolutely terrible day and they really need this paper, and the review is actually very, very bad, like actually does make like a super trivial dunk on the paper. And, you know, I'm not sure what happened right here. If you were ever inclined to write a rebuttal like this, just sleep, go to sleep, wake up the next day, breathe, and realize that it's kind of useless, even if it's probably true. Another worrying issue tweeted out by Stella Biederman is the following. So one reviewer criticized this model for that it is not acceptable to only compare with publicly available models, meaning that the paper should also have compared with non-publicly available models. Now, there is, of course, a debate to have right here in order to properly compare compare to someone's model, you need to have access to it. On the other hand, there has been a long history of science where people just hadn't been putting stuff out into open source, and you'd essentially just have to take the numbers from the tables from their paper and then put those into your paper and essentially just believe what they said. It's possible that the reviewer here is of the stance that, look, you can just take the number that they claim and put them there. On the other hand, it's also entirely fair to say that, well, I don't have access to their model, I can't verify their numbers, and therefore I'm not going to put them into my paper. The crux is obviously if that fact that you leave these things away that aren't public also makes your method appear a lot better in comparison, because the only actual competitors to your method are closed source and only have some number in some paper. I don't know what's the correct answer right here, but it's certainly worth having a discussion about. And lastly, and you might actually have heard of this one, is this paper called Variance Reduction is an Antidote to Byzantines, Better Rates, Weaker Assumptions, and Communication Compression as a Cherry on the Top. People do get creative with titles these days, but the problem that one reviewer here had is with the word Byzantines, which the reviewer claimed to be disparaging of the whoever people consider themselves Byzantine. Now, Byzantine is a term that's been long used in various fields of analysis, security, cryptography, I believe game theory. So the term is very well known and is an established technical term. However, the reviewer is of strong opinion that that is a term that contains prejudice and is derogatory and is denouncing the ethno-religious practice of some people. Now, the reviewer bases their opinion strongly on the fact that the ICLR Code of Ethics says you must respect cultural heritage of others, and repeatedly claims that the usage of the term Byzantine in this work is a violation of the ICLR Code of Ethics, whereas the authors claim this is a technical term, it's been used for a long time, and it is disparaging to absolutely no one. Now, the conversation goes on and on. I believe there are over 36 comments in this thread, including some other people coming in and saying, hey, I'm actually considered Byzantine and I don't have a problem with the term, so don't defend, us. While the reviewer did make some suggestions for other terms, such as deviant, but the authors pointed out that none of these suggestions capture the term in its full existence or in how people actually use it. As the debate goes on, you'll see the reviewer shifting their stance a little bit from the fact that it's just not appropriate to use the term, that the paper also isn't technically correct. But I strongly believe that the reviewers only introduced that point after the discussion had been going on for a while, and they realized they needed to make another stronger case on scientific terms. Now, the problem here is that on open review, I believe you can't see the modifications, so we have no idea. These comments, they were all changed around. Even the original comment is changed around to include some other feedback and so on. So it seems the timeline here is a little bit murky. The authors here also point out that this point, the point that the word Byzantine is inappropriate, was apparently initially the only criticism of that reviewer, or the only real criticism, but the reviewer gave the paper a really low score. And if you know anything about conferences, most meta reviewers just kind of look whether there is one bad score, and then the paper already has very poor chances, or they look at the average, which would obviously be decreased strongly by one bad score. So essentially, the reviewer held the paper hostage a little bit and wanted the authors to change the wording. The authors even agreed to abbreviate the word Byzantine to biz, like the short form biz, because they just didn't agree that any of the other terms would do the technical nature justice. The reviewer disagreed that that would actually solve the problem, and essentially said that even if they were to change the term, they would now expect not only to not use that term, but also the paper to contain a discussion of why the word Byzantine is not appropriate, or at least a moral struggle of the authors are bringing this up of why this is problematic. The reviewer again repeatedly and insistently claims that it violates the ICLR Code of Ethics and holds that as a stick to hit the authors with, code of ethics. This is against the code of ethics. What's interesting is that at some point, the program chairs commented on this as well, saying that the program chair committee and ethics chair have been following this thread closely. Upon preliminary investigation, the ethics chair find that the use of the B word, it's not the B word, is a possibly emerging issue, but not yet a major ethics issue that could justify rejecting research. There seems to be no widespread agreement that the B word is offensive. This discussion between reviewers and authors is still valuable to our community, which raises awareness of this potentially emerging issue. We appreciate the thoughts from the reviews, and they said that this is essentially now resolved by saying, you know, reviewer, you made your point, but we don't agree with the point. The reviewer responded, again, lengthily pointed out that this violates the ICLR code of ethics. Now, in the end, you could say it's all good, and the program chairs came in and essentially squashed the reviewer and said, okay, the paper is fine, you can use the word Byzantine, it's not problematic, all good. But I strongly actually believe that this is a big win for this reviewer right here, because the ethics chair, the appropriate response would be, shut up, you're an embarrassment to the scientific institution, and you're barred from reviewing any more papers for any other conferences. This is a joke, shut up. But they didn't do that. They essentially said yes to the reviewer. They essentially said, yes, it's a possibly emerging issue, because they've seen that there was quite a bit of uproar in the community that such a, what is essentially a technical term that is no one, absolutely no one except this reviewer feels is not appropriate was used. The ethics chair said, yes, it's possibly emerging. So this is like a groundwork for the future. This is how these things slip in there. I have full conviction that people who write these codes of ethics do so with the best intentions, at least most of them. I do believe some of them predict exactly this, and this is how you again and again slip these things in. So one person makes a fuzz, you take the temperature of the community, it's like, not yet ready, but we have now precedence, right? So at the next conference, the same reviewer can make a fuzz again, and they can point back and say, well, other people, you don't know it's the same reviewer, other people have said this before, so actually this might actually be problematic. And the ethics chair here seems to be bound by the fact that someone said, this is ridiculous, shut up. However, they do so in the most lenient way, in the most way that guarantees that in the future this will actually become a problem. So, in my opinion, big win for the reviewer right here, big win for the complainers, and I don't like it. Google has a new paper called Efficiently Scaling Transformer Inference on how they scale their big palm models on TPUs. Now, it is not going to be very applicable for most of you, but in case you care on how they enable something like 32 larger context lengths and super duper flops and super duper hardware utilization during large batch processing, give this paper a read. Also from Google, the Google Research blog has an entry called Infinite Nature, generating 3D flythroughs from still photos. This is on top of a paper that they published at ECCV, which generates infinite views or infinite fly-throughs, as the title says. And the cool thing is this happens from still images. So you can give a single image and it will generate a fly-through from that image. They use various techniques for that, but the base idea is that you take an image and you predict its depth map, so how far away all the stuff is. And then you use that in order to render the image from a slightly different view. If you know how far away all the things are, you can position your camera slightly differently and you can still determine where the pixels go. Now, this will leave some pixels to be undetermined because you can now see behind things that you didn't see before. And then you have another model here in this refine step that essentially fills in these missing pixels. And then you repeat. Again, you pose the depth map, you adjust your camera position tiny bit, and then you fill in the pixels that are missing. In order to train this, it's not exactly super easy, but there are some various techniques called cycle consistency, or what they do right here, they have an adversarial setup. They have a discriminator to determine whether after a number of steps the image still looks like it's been generated from a real like nature image. And if you backpropagate that error, then you can generate very long, very high quality fly-throughs through nature. Here you can see a bunch of examples. What I do find interesting is that they also added a specific sky model in order to make you feel like the sky is more real. I suspect their original works that the sky was often the problem and looked unrealistic. So now everything that's sky here is produced actually by a separate model, as far as I can tell. Paella, I hope that's how you pronounce it, is a new paper that also does text to image. However, this one is speed optimized. So in order to do diffusion, you have to take some bit of noise and then run it through the diffusion process, step after step after step. There are various techniques to speed this up, and Paella supercharges them and manages to do the whole diffusion process in only 10 steps, which amounts to only 500 milliseconds. So within only 500 milliseconds, you have a high quality image from a given piece of text. Again, amazing progress in a field that is super young. Check out Paella. There is a corresponding paper to it called Fast Text Conditional Discrete Denoising on Vector Quantized Latent Spaces. Now, if you enjoyed the previous paper on how to scale up PaLM, then you might also enjoy MultiRay, which is by Meta, and the blog post is called Optimizing Efficiency for Large-Scale AI Models. This describes the system called MultiRay. Now, I've read the blog post, and I have to say it's kind of wishy-washy. You have to guess a lot of the stuff. They just kind of describe in words what it does, and they link to various things that they've done, but I can't exactly read out, what precisely they're doing right here. But if you need some inspiration of how a system like this would work, or some hints of how this is really done in practice at scale, then give this blog post a read. arXiv pairs up with Hugging Face. So previously, Hugging Face has acquired Hugging Face spaces from Gradio, which allows you to make little demos out of your Hugging Face repositories. And now arXiv includes those spaces. So if you upload a paper to arXiv, you can attach a demo from a Hugging Face space. So people can directly on arXiv try out your model if you have one, or your technique if you have one, and do so interactively. This is very cool, and obviously I'm a big fan of integrating interactive things into our very old format of 8-page PDFs. Okay, we got a bunch of new models this week. The first one is Alt Diffusions by Flag AI, which is a multilingual diffusion model. So this is essentially stable diffusion, but multilingual, as you can see right here: English, Chinese, Spanish, French, Russian, Japanese, Korean, Arabic, and Italian. Next is Demux by Meta, which is a music source separation model. So this thing, you can put like a song in there, and it will separate the sources, meaning it will separate things like drums and vocals and isolate those. Perfect for practicing something, doing karaoke, and whatever you want to do with it. The paper is called Hybrid Transformers for Music Source Separation, and it's on arXiv. There's a new multilingual clip available from Lion, trained on their own dataset, the Lion 5B, and it reaches 77% zero shot on ImageNet in English and around 55% for Italian, Japanese, and Chinese, and supports over 100 languages. The cool thing is that it's very efficient in training because it uses locked image tuning, which we've discussed previously in a video. So check out the model and check out locked image tuning if you haven't seen it yet. It is really a cool paper and a cool and simple technique. In other news, a research group at the Citizens University of New York has released a model that can accurately predict the human response to novel drug compounds. Now, they're certainly not the first people to release such a model. This has obviously been going on for as long as data science has existed, but also it's cool to see that even in this front, in the drug discovery front, giant progress is being made on the back of what started out as cat image research. All right, some helpful things for this week. We have quite a lot to get through, so let's get into it. This is a pixel art sprite sheet generator. If you're into old games, into sprite animations and so on, this is a stable diffusion based model that will create the sprites for you given a description. Look at this, I typed in Fat Joey. Prompt Extend is a model that will extend your prompts. So here is an example. You type in psychedelic liquids space and it will append what it thinks that stable diffusion needs to give you what you want. So this is like a little bit of a translator between human input and whatever a very competent human using stable diffusion could do with all the modifiers such as concept art, sharp focus, illustration, Unreal engine, and so on. There's a new blog post on Hugging Face telling you how to fine-tune Whisper for multilingual ASR, but you can fine-tune Whisper for whatever you want. This blog post is your point of entry. Dream Texture is a plugin to make Blender interact with Stable Diffusion. So here's a demo. Person types into Blender whatever they want as a texture in terms of text, and then bada bing, bada boom, apply, and it's now in the texture. Absolutely great. The YouTube channel Mutual Information has a series on reinforcement learning that I can highly recommend. They spent a lot of time on this, and I hope it is helpful to anyone who's looking to get into RL. Lovely Tensors solves a problem we all have had in the past. So if I just want to print some tensor, I'm gonna get this, and it's absolutely not helpful at all. As soon as your tensors go beyond like 4 or 5 values, it's useless to just look at them. So all you do is you import Lovely Tensors, you monkey patch that stuff in, and all of a sudden, if you print a tensor, a NumPy array, a torch tensor, whatever, it will give you the shape, the amount of elements, statistics, the means, the standard deviations, and so on. This is a much better way to look at tensors. Now, if the tensor is small enough, it will actually show you the values, but as soon as it's bigger than that, it will give you much more useful information. So here, it warns you that there is infinities, there's nans in the tensors, and so on. And even here, it tells you, well, this one is actually all zeros. You can still get back to the original tensor using sort of property access. Here you have verbose access that will give you the values even if it's large, and here you get just the plain old way if you really want that. There are various helper methods around this, also to show images, to show statistics, to show channels, and to show things such as different filters in a stack of convolutional filters. I'll leave you to explore all of that yourself, but if you work with tensors a lot in an experimental sense, this is surely worth it. GPT index is a technique to build an index out of files using GPT. So this uses GPT to essentially take a bunch of files and then, for example, recursively summarize them so that you essentially have a structure where you have a summary on top of a bunch of stuff, and then if you like one of them, you go into it, and then you have summaries of the sub stuff that is there, you go into that. It's kind of an experimental, I want to say this is a bit of a new way of thinking about what we could do with these models in order to organize information now that we have generative capabilities, and I like that people think out of the box. So if you're also interested, check out this repository. There's a new upscaler for Stable Diffusion made by Rivers Have Wings. The notebook is by N. Shepard, and compute has been sponsored by Stability AI. The notebook here runs you through the whole process of upsampling, and it gives really cool results. I've previously talked about DagsHub. DagsHub is like a bit of GitHub for machine learning, and I know a lot of places claim this nowadays, but DagsHub really believes in the open source paradigm, and now they release something they call direct data access, and it's essentially a technique to stream down and upload version data to some place. So it essentially connects a DVC, which you might know as like a data versioning tool, with a transparent approach where you don't need to like pull all the whole data at once or, you know, stream it in some custom way. You can just treat it as if it already existed, and magically the library in the background will pull down the data as you need it in a streamed fashion. So no long waiting on data to arrive. You can just simply like go train, and even if you don't have space for the whole data, it will still work. Now, I don't have exactly time here to explain you all of the things that you can do with it, but the install is really simple. You essentially install their hooks and everything works just transparently and magically. So if you're interested, check it out, and also check out their blog. It's regularly updated. For example, here is how to build an end-to-end active learning pipeline with fully open tools. GENV is a GPU environment management tool. Lets you easily control, configure, and monitor the GPU resources that you are using, and it is intended to ease up the process of GPU allocation for data scientists without code changes. So this is in case you're in some lab and you share GPUs with others. This tool is a must-have. I wish that this had existed during my PhD. It manages local GPUs, remote GPUs, cluster GPUs, and so on. You can reserve GPUs, free up GPUs, essentially whatever you want to do. It has even a VS Code plugin, so if you're at all using GPUs, and especially if you're sharing them, consider this tool. MBXP is a multilingual benchmark for code completion in 10+ programming languages. TSAI is an open source package intended for applying deep learning to time series on top of PyTorch and Fast AI. Colossal AI has released 2 blog posts, both pertain to better and faster and cheaper training of models. The first one is what they call AIGC, AI generated content, which essentially means image generation models. And the second one is for structure prediction of protein monomers and multimers. And both times they're able to speed up these models by a lot. Now the code is openly available, so do go and check it out. And the performance gains here are not only during inference like we saw before, but this in fact provides, for example, for Stable Diffusion, 6.5 times faster training and pre-training cost savings. So the hardware cost of fine-tuning can be almost 7 times cheaper than if you were to do it in the vanilla way. HapVid is a benchmark for tracking any point in a video. SuperGradients is an awesome library to build, train, and fine-tune production-ready deep learning state-of-the-art vision models. Now, we've seen a lot of libraries that, claim to just make stuff better. If you're into vision, I believe having like a library that's specific for vision, such as semantic segmentation or bounding box prediction, or even image classification, it really pays off to have a library that's dedicated to your field, especially if it's something like vision, where we have a lot of custom techniques that make these models just so much more efficient and better. But not only that, SuperGradients also provides a lot of pre-trained checkpoints. So even if you're just into using some models, this library might be good for you. Shumai is a network-connected differentiable tensor library for TypeScript and JavaScript. As you can see in this demo, what you can do is you can define neural networks in TypeScript, and then you can distribute them over multiple places, so over multiple machines. And you can use the await, like the async await syntax from JavaScript in order to ship data to some other machines or call some function on another machine. And the library handles everything from forward propagation even to back propagation and training. It's really cool, and the API for this looks quite clean. Safe Tensors by Hugging Face is a new format to store and load tensors safely. I've previously done a video where I showed how you can smuggle remote code execution into the Hugging Face hub, because the models essentially use the PyTorch loading function, and PyTorch in turn uses the pickle function by Python, which executes arbitrary code. Safe Tensors is supposed to alleviate that by defining a safe, fixed, and simple format to store tensors. Now, obviously the trade-off here is that you can't store arbitrary things anymore. If you want to store arbitrary things, you have to allow arbitrary code to be executed. So while I expect that a lot of architectures might switch to something like safe tensors, it is not a full solution for the problem. For better or worse, research will come up with new things, new ways of doing things. And if you constrain yourself to a particular way of doing things, then that will always not be enough. However, it's mostly gonna be enough. Velo is a learn optimizer. And the cool thing here is that it really seems to be better than, or at least on par, with very hand-tuned optimizers. So you might know optimizers as stochastic gradient descent or Adam or something like this, but it is possible to learn an optimizer. So to learn a system that controls the optimization behavior of a training run of another system. These people have taken a lot of different ML problems, a lot of different networks, have run optimization problems on them, and have essentially learned an optimizer that optimizes all of these different problems well. So that's what we consider a learned optimizer. And this one really seems that for many problems, especially like mainstream problems, it works really, really well out of the box. So without you having to tune, the beta 2 parameters and the learning rate and stuff like this, you just apply it in its default configuration, and it does a pretty good job. This is super important if you want to do rapid prototyping, rapid exploration of some new ideas without doing a giant grid search over all the parameters. The Merlin data loader is a data loader specifically for recommender systems. Recommender systems have, a few extra or a few special requirements. Namely, there's often quite few data, I want to say, compared to something like an image classifier. Like the data points are mostly tabular and they're not as many. So loading from disk, and loading like pairs and stuff from disk often can become the bottleneck. So a data loader is super important here, and the Merlin data loader promises to be over 10 times faster over native framework data loaders. If you're into recommender systems, try this out. Loda is an assembly language, a computational model, and a distributed tool for mining programs. This topic is very far away from me, but some of you might actually be interested. So if you're into integer sequences, there are these online encyclopedias of integer sequences like 1, 2, 3, 4, 5, and so on. So there's sequences of integers, and the question is always, what's the program behind them? Like, can I come up with a piece of code that produces that integer sequence into perpetuity? And, 1, 2, 3, 4, 5 is quite simple, but it gets complicated very quickly, and especially to teach machines to come up with the rules behind a sequence is a very challenging problem. So Loda is a system that allows you to mine such programs. Essentially, you can run it and it will crank, and intelligently search for these programs. But not only that, it is also a distributed tool for doing that. So you can distribute, you can partake in mining of such programs, and much more. So as I understand, this is about what a Loda program looks like, or what it searches for. So here you can see one of these sequences, and this is apparently the program it comes up with. It looks pretty interesting. If you're interested, check Loda out. NumGa, not Numba, NumGa is a library for geometric algebra in JAX and NumPy. If you're into geometric algebra, here's the example of a rigid body physics engine with a constraint solver, then this library might be for you. MTEB is a benchmark for text embedding. This is from similar authors as the Bayer benchmark, which is a retrieval benchmark, but this goes further. This is a benchmark that covers 8 embedding tasks over 56 datasets and 112 languages, and it also evaluates in this paper already 33 models on that benchmark. So the goal here is to find the one unified text embedding that covers all downstream tasks, and the status this far is that that universal embedding hasn't been found yet. The leaderboard shows that some models are good at some tasks, other models are good at other tasks. So the holy grail of text embedding is still somewhere out there, and this benchmark might prove that you have found it. Okay, the last cool thing I want to show you is Natbot, and this is already a little bit older. Nat Friedman tweeted this out in September, but essentially he managed to connect GPT-3 to the browser, to a web browser, and just let it interact with the web browser by prompting it in an appropriate way, given the website's HTML structure. So apparently the original idea comes from Sharif Shamim, and Natbot has a repository on GitHub. Look, it's just one Python file. I know half of you are super cringing right now, but research be research. And if you want to figure out how it's done, how Natbot works, and if you want to give it a shot yourself, might be really cool to do. So please do. All right, that was all from mlnews. This was a big chunk. Thank you so much for being here. Thank you for supporting the channel. Come to Discord if you're not already on it. Link is in the description. We have fantastic paper discussions every week, and we talk general machine learning every day. With that being said, stay hydrated. Bye-bye.